Hello, welcome everybody to your unit on vectors. This is unit 5.1. The name of it is vectors. Vectors may or may not be familiar to you. This is a link kind of section. The link is between science and math. There's a lot of math in this section, but vectors are used in a lot of story problems to solve kind of science and physics types problems. The first thing I want you to know about vectors is that all vectors have two things related to them. One of them is a magnitude, and magnitude basically means how long a vector is. What is a vector? A vector just looks like this right here. It's an arrow. So that's a vector. That's a vector. The first thing you need to know is that the length of this vector from here to here, like 3 inches, 5 inches, 10 feet, 100 meters, that is what we call the magnitude, how long it is. It also goes in a direction, because looking at this vector right here, it could be traveling upward, or it could be kind of traveling downward. So there's always like a head and a tail, and the tail is kind of where this arrow is, and it tells you which direction it is traveling. So if you look at the one that's on the picture here, this vector right here, that's kind of going up and to the left. There might be an angle measure associated with it, and that kind of tells you how many degrees it's going in a certain direction. But it also has to tell you how far it went. It reminds me of a ray in geometry. So if you can kind of think of it as a ray, the only difference is rays, the arrow signifies it keeps going and going and going and going. But in vectors, this is the stopping spot right there. That's where it stops. Now, in terms of direction, there are lots of different ways, probably like 100 that you can describe the way a vector goes. I'm going to tell you the two most popular ones. The most popular one probably is calling this 0 degrees, the horizontal. And then if you went to here, this would be 90 degrees. Halfway around a circle is 180 degrees. This would be 270 degrees, and if you get all the way back, it's back to 0 or 360, a full turn. This is probably the #1 most popular way, but a lot of times vectors, since they relate to the real world, they will call this north, east, west, and south, kind of like on a compass rose. And they might say things weird like 20 degrees north of west. Well, here is your west degree marker, and if I go north of that 20 degrees, this angle right there, that's the 20-degree angle. Excuse me. So that's kind of the background. Component form it kind of looks like an ordered pair, but it's a little different. That's why instead of putting a parentheses around these two numbers, you'll put little like angle-y things. They look like this, kind of like less thans and greater thans, but they're not really that. And the first number, just like an ordered pair, tells you how far the vector moved in the x or the horizontal direction. And that means left or right. And then the second number, it's the y direction. That's how far the vector has moved up or down, or vertically. If you think of a plane moving too, that's a perfect example. A plane could move. It could be moving like, I guess, northwest this way, but it had some movement this way, and it had some movement this way. It just might be moving at an angle, but it also has moved west, and it also has moved east. I'm sorry, north. And that's what a component is. It's breaking it up into its two components. And then here's my little picture here. All vectors have a head where the little arrow is. That means the direction it's going, and a tail where it began from. Math problems here. Here's example 1, kind of a picture of, the Midwest here. It doesn't really matter. And a question for example 1, and of course don't forget to pause these videos if I'm going too fast. It's to write component form of this vector. So this vector I'm going to say has a magnitude of 20. Now the 20 could be speed. It could be a car traveling 20 miles an hour in this direction that you see right there on the red vector. It also could be a length. It could be 20 meters, feet, miles, kilometers, anything like that. It could actually be an acceleration. It could be anything. And the 120 degrees, since I don't really say anything, it's standardized by this is 0, this is 90, so 120 degrees would be like 30 more degrees in that direction. So I'm going to then take a look at this, and the component form, basically, my answer is going to have to be between these little braces here, it's going to have to be, let's call this 20 meters, just for fun. A distance the object has moved x, or horizontally, and a distance the object has moved y, or vertically. And all of this really has to do with trigonometry. Usually vectors are one of the next things you study after you've had an extensive study of trig. So if I were to draw this a little bit bigger, I have this component, which is what happened to the plane, the bug, the man walking, whatever. He walked in that direction, which means he went an amount this way, horizontally, and he went an amount this way, vertically. The amount he went this way is going to be filled in the x direction. The amount he went this way is going to be filled in right here in the y direction. So I'm going to put the 20 here. The only other thing you need is you need an angle measure. Now if this is 90 degrees straight up here, then you could figure out this angle or this angle, because there's two triangles there. The one I have over here, which is this triangle here, and I'll put orange. You could also use this one. Those are both really the same triangles, just turned around. I always like to use, I'll put it in white, this one. If you get it in this form, it's always done the same way. So that's why I drew it like this. Now the question is, how many degrees is that? Well, if I've gone 120 from here to here, a half turn is 180. How many more degrees do I need to go? 120 from 180, that's 60 more degrees. So this angle is 60 degrees. This component right here, using SOHCAHTOA, I'm going to write it under here, is solving. So adjacent hypotenuse. This is the adjacent, this is the hypotenuse. So cosine, cosine of 60 equals adjacent. I don't know. I'm going to call it A for adjacent, or you could have called it H for horizontal direction, over hypotenuse. Hypotenuse is 20. Multiply both sides by 20. A equals whatever 20 cosine 60 is. Plugging into my calculator, 20 times cosine 60, that's actually a whole number. It's 10. That's beautiful. So that is my horizontal component, my x component, my x direction, just like an ordered pair is x, that goes first. Then when I'm trying to do my y component over here, I'm going to put my work there. If you do it always from the horizontal here, this is always going to be sine, opposite over hypotenuse. So the sine of 60 equals the opposite, which I don't know, over the hypotenuse, 20. The opposite is going to be 20 times sine of 60. Plugging that into my calculator, I get 17.32. That's not as pretty. Since that's a vertical movement, how far he went up, 17.32 goes there. This represents the component form of the vector that's in red up here, and it means that if 20 is a distance, we traveled 10 units horizontally from our starting point, and 17.32 units, feet, meters, whatever, vertically. This is a tricky lesson, so it's going to take a little bit more time. Example 2. Given the vector v has an initial point, negative 3, 5, and a terminal point, negative 1, 12. Well, this is about an ordered pair, so I'm going to make a quick sketch. Negative 1, 2, 3, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 is here. That's the starting or initial. Terminal means end. Negative 1, 1, 2, 3, 4, 5. I got to keep going up here. 6, 7, 8, 9, 10, 11, 12. Way up here. Since that's terminal, I will draw my vector. It goes like this. The question is component form again. This is way easier with points in ordered pairs because this is how far did you move horizontally and how far did you move vertically. So using a different color here, I moved horizontally 2 units. I could get that by doing a math problem and just subtracting the x values. So the x values are the ending point here minus the beginning point, and that means I moved 2, or you could just count 2 units. So that's the horizontal way and the vertical way. How far up did I move? And that would be like a 12 is the ending point, take away the beginning point, 12 minus 5 is 7. I've moved 2 units right, 7 units up. It's almost like a slope, okay, but it's not written as a fraction, it's written as a component in vectors. Subtract your x's, subtract your y's. This happens in the real world, such as something simple as a dog leash. This example 3, you don't have to write down. Just kind of look at it, and I'm going to kind of scan it for you. If you're pulling Fido, this is Fido here, and you're pulling him on a dog leash in this direction, that's what the blue arrow is for right there. Let's use my lightsaber since some of you request that. Oh, here we go. So this right here is your vector signifying you're pulling upward. So instead of a length, it's actually a measurement of force, which in the physics world is called newtons. If you don't know that, it's not the end of the world, but just it's something good to know. 40 degrees, that's the angle measure that you're pulling up Fido's chain with. These are the components, 38.6 and 45.9. How did you get them? You used trig. So looking at my right triangle here, 40 degrees, you did the sine of 40 is opposite over hypotenuse, cosine of 40 is adjacent over hypotenuse. You solve the same way and you got the numbers. If I had to write this in component form, this problem here would be doing the math, 45.9, it's all there for you. That's the amount of pull you're pulling Fido backwards, because that's horizontal, that's this direction. And 38.6 amount of force, he's being pulled upward. So just another application problem. The last one, I got one more. Here's just a kind of like a finishing problem, and this is a problem about kicking a ball. Here's a little soccer guy. He kicks the ball. He kicks the ball at a certain angle. The angle is 20 degrees. This is now a speed instead of a distance problem. So this ball is traveling horizontally at a certain speed and vertically at a certain speed. The resultant speed is 25 meters per second. This is the x component, this is the y component. Let's work them all out. Now notice how you're seeing the common theme. The x value is always going to be cosine if you pick this angle, because that's going to be adjacent. Cosine of 20 equals adjacent over hypotenuse. And then adjacent is whatever 25 cosine of 20 is. That ends up to be 23.49. And then for the how fast the ball is traveling upwards, notice I'm saying fast because the units on this are meters per second, so it's not length again. That's the difference between vectors and just standard trig. Sine of 25 equals the vertical distance. This could have been horizontal distance, either way, or you could use adjacent and opposite like the last one. I'm sorry, this is 20, because that's the angle measure, and then over 25. Whatever the vertical speed is, it's 25 times sine of 20. Vertical speed is going to give you 8.55 when you plug that into your calculator. If I wanted component form, I could have asked you for either one or the actual whole component. You then would say the horizontal distance comes first. That's the horizontal distance, 23.49, and the vertical speed, I'm sorry, not distance, speed, is 8.55. This is a tricky lesson, so we'll definitely give some time in this to class to kind of work it out. Thanks for listening.